Page 137, lesson 2.9 is on percents. Some of the stuff we've worked with before. Some of it we maybe haven't, so if we look at the top of the page, some recommended daily intakes of vitamins are shown. Carrie consumed 10 milligrams of niacin today. Her brother consumed 11 milligrams. Who consumed the greater percent of the recommended intake, and how do you know? So what it is, there's different amounts, different recommended amounts for males and females for some of these things they've got listed here. So for males, it's recommended 16 grams, or 16 milligrams rather. For females, it's recommended 14 milligrams. So if Carrie is female and she consumed 10, what we could do is say that's 10 out of 14. So 10 out of 14, maybe I'll come over to the side here where we can read it. 10 out of 14, what you could do is divide that out and then move your decimal over 2 spots. That's about 71%. Her brother is 11 milligrams out of 16. Divide that, move the decimal over, is about 69%. So Carrie had the greater percent of recommended intake. So there's different ways of working out some of the problems that we're going to be doing in this lesson. One option is what's called the percent proportion. Percent proportion, they have it set up A over B equals P over 100. A little bit different way of putting this that might make it easier for you to follow. We could say it's the part over the whole equals percent over 100. Another way that seems to kind of follow along with how these problems work, I'm not a big fan of this, but if you look at the problem and you look for the words in the problem, is over of equals percent over 100 is another way we can kind of get these proportions set up. Again, that last way, it's not really something that's going to stick with you, I don't think, and not really a way that I would recommend, but it does work. And again, this is one way of setting up these problems. We'll talk about a different way also later. So if you look at problem 1, what percent of 56 is 42? So if you can look at it, our part is 42. Our whole is 56, and we're trying to find what that percent is. Once they had that proportion set up, they went ahead and cross-multiplied and then divided by 56, and they got 75. We're finding a percent, so that means 75%. Just to illustrate the other method, like I said, I don't think it's going to stick with you for remembering it as well long term, probably. Would be this method. So it is 42, and it says of 56, and then we're trying to find that percent. If you'll notice, we have the same setup as they have in the book. And what we're saying, once we get our answer, once we get 75%, and that's our answer, if we put that back up in the problem, what we're saying is that 75% of 56 is 42. Okay, 75%, so 3/4. That seems pretty reasonable. And so to check that, then you could change that percent to a decimal. So 0.75 times 56 should equal 42 if we did that correctly. So if we look at the got it one, what percent of 90 is 54? The 54 is our part, and the 90 is our whole, and we're trying to find the percent again. So we can go through this. Another option you guys have rather than doing this proportion would be that you could just take 54 divided by 90, get that as a decimal, and then move your decimal 2 spots to the right. So if we divided this out, this would be 6/10. Move your decimal 2 spots, which would be 60%. Otherwise, over here, you can work with this. One thing you can do if you want is that sometimes we can reduce ahead of time. And by reducing, we might come up with a pattern that wasn't there before. One other option besides doing the cross multiplying, besides reducing and finding the pattern, you could say that the variable is being divided by 100, and then you could multiply by 100 on both sides and you get the same answer. Another option we have when we're doing these problems is we can do the percent equation. This is my personal favorite, is the percent equation we've worked with before. Percent equation, basically, there's 3 things to remember. One thing is if we get a percent, we're going to change the percent to a decimal. We need to remember that is means equals, and of means multiply. And like I said, it's up to you which way you want to do these problems. To me, this is what stuck with me better, that I could remember it, you know, even years down the road, not forget about how do I work this out. So the book talks about this stuff. I'm not even going to mess with that. Basically, just like we said. So if you look at problem 2, it says what percent of 40 is 2.5. I'm just going to transfer this to an equation. So it says what percent, that's what we're trying to find. If you want to do P for percent, you can. We use X a lot if you want to use X. I've had people ask me before, can I put X percent to remind me that I'm finding a percent? I'm okay with that. Just remember X percent is your variable that you're solving for. And then we've got of, which means times. 40 is means equals 2 5/10. And then we've got an equation. We're just solving the equation. It's always just going to be a one-step equation. So we can say the variable is being multiplied by 40. I'm going to divide by 40. And then what happens when you divide that out, you're going to get a decimal. What we have to remember is we're trying to find the percent. That's the percent as a decimal. So we have to move our decimal 2 places to the right, which would be 6.25%. And so what we're saying is 6.25% of 40 is 2.5. And again, you can multiply that out to confirm that you have the right answer. So if we look at the got it, what percent of 84 is 63? It talks about here, it says use the percent equation to solve. I think it's good if you guys at least consider the two different options. But then ultimately you can think about which method you prefer. On your test, I'm not going to make you do these problems a certain way. So it says what percent, so we can do P for percent or X percent if you want. Of means we're going to multiply by 84. Is means equals. 63 means 63. And then variables being multiplied, so we're going to divide. And that's going to give us a decimal here. So that comes up as 75 hundredths, and then we move our decimal 2 spots because we're finding a percent. So 75%. So we're saying 75% of 84 is 63, and again we can check that if we want to. So problem 3, instead of finding a percent, we're finding a part. So a dress shirt normally costs $38.50, is on sale for 30% off. What is the sale price of the shirt? So what we could do, what I would probably do is just say it's 30% off. So I would just say, what's 30% of $38.50 would be one option. We change that to a decimal, the percent to a decimal. We multiply that as 1155. What that means is we're going to be saving 1155 off the regular price. And then if you subtract that, you'll get $26.95. Another option you have is to think about, if you're paying full price, you're going to pay 100%. If it's 30% off, then, so this is another option. If it's 30% off, means you're going to pay 70%. So you're going to pay 70% of $38.50. Change 70% to a decimal and multiply, and you will get $26.95. So whichever way you want to do that's fine. The book's doing this percent equation and everything, you know. I don't think we necessarily have to do an equation here, but just some different options for working that out. So on the guide at 3, a family sells a car to a dealership for 60% less than they paid for it. They paid $9,000 for the car. For what price did they sell the car? So one way of doing this, we could figure out what's 60% of 9,000. So change percent to a decimal. Of means multiply. That's 5,400. That's how much less that they got than what they paid for it. So we could then take 9,000 minus 5,400, which would be 3,600. Another option would be if they got 60% less than what they paid, then they got 40%. So we could figure out what 40% of 9,000 is, which would be 3,600. Whichever way you want to do that is fine. Problem 4, we are finding the base. So it says 125% of what number is 17.5. So we can translate that over into an equation. So I technically am doing this a little bit different than the book. I'm just straight up translating this over. So 125% I'm going to change to a decimal. Of means multiply. What number is what I'm trying to find. Is means equals 17.5. So the variable is being multiplied. We're going to divide by 1 25/100ths. And when you divide like it shows in the book, that's going to be 14. This time we're just finding a number. We're not finding a percent, so we don't have to move our decimal over at all. So if you want to use P for percent and then remember to move your decimal and put the percent sign if you do it this way, whatever you need to do to make sure that you do that. So what we're saying is 125% of 14 is 17 5/10. It's over 100%, so it's going to be bigger than 14. And again, you can work it out just by putting the 14 back in your equation here. You should be able to check that you've got the correct answer. So if we look at the got it for, 30% of what number is 12 5/10. Solve using the percent equation, then solve using the percent proportion. I'm not going to do that. I'm just doing the equation. So 30%, we can change that to a decimal. Of means multiply. What number is what we're trying to find. Is means equals 12.5. Variables being multiplied, so we can divide by 30/100ths. Whoops, that doesn't cancel. When you divide that out, you're actually going to get a 41.6 repeating. You might know that as 41 2/3, or otherwise we could have it as an improper fraction. Kind of like if you multiplied both of these by 10, that would clear out your decimal, which would be 125/3. So probably one of those two would be a good answer to have. It is technically the 41.6 repeating. Generally, we'll try to get them as fractions if we can. Bottom of the page on 139 talks about simple interest. Is either money that you're getting or money that you're going to owe in addition to what you're borrowing. So kind of like maybe at this point, if you have a bank account, you have a savings account, then you're probably not getting much on it, but you're at least getting a little bit of interest on your money for them having it in the bank. And then what happens is basically then they loan your money out to people that are buying cars and houses and things, and they charge them a higher percent than what they're charging you, and then that's how they're able to pay their employees and stay in business. So the formula for this is I equals PRT. On the formula, I is the interest, which is either how much money we are having to pay extra or how much money extra that we're getting. P is the principal, which is the money that's invested or borrowed. And then R is the annual interest rate as a decimal. And T is the time in years. So for example, you invest $50, 3.5% a year for 3 years. Interest you earn, we're just substituting in. Principal is 50, interest rate 3.5% as a decimal is 35 thousandths times 3 years. The variable's by itself, so we're just multiplying these three numbers together, and then we're getting that answer, 525. When we do these problems, there's 4 variables. As long as they give you 3 variables, the numbers for those, we can solve for the 4th variable. So here's some common percents as fractions, if this might be something helpful for you on different problems as you go through. So you can see those there. Problem 5, interest formula problem. You deposited $840. Interest rate is 4.5% per year. You want to keep it in the account for 4 years. How much interest will you earn? So they just took the formula. The principal, the amount they invested is $840. 4.5%. They changed that over to a decimal, moved the decimal 2 spots to the left, and then the time is 4 years. And again, at that point, it's just multiplying those together. You get 151.2. Since we're talking about money, we can add a 0 on the end, which is $151.20. A follow-up question they could ask would be, what is your account balance after those 4 years? And if that was the question, you would have to think about, you had $840 and you're getting $151.20 in interest. So now your account balance would be $991.20. So if we look at the got at 5, you deposited $125. Simple interest rate of 1.75%. You earned a total of $8.75. How long was your money in the account? So this one's a little different. We're not just finding the interest, we are finding the time this time. So we deposited $125. That's the principal. Interest rate's 1.75%. We're going to change that to a decimal. Move our decimal to the left 2 places. So 0.0175. Interest is what we earned, is $8.75. And the time is what we're trying to find. So if we set this up, we can simplify on the side with the variable. We can go ahead and multiply the 125 times 175 10,000ths, and we get 2.1875. And then they're multiplying, so we can divide by that. And it doesn't look real great right now, but that comes out as 4. So that means 4 years that you had that money in the account in order to earn that $8.75. So the concept summary, they're just kind of recapping some different things. Showing over here different ways that we would work these problems out based off if we were using proportion, percent proportion, or percent equation. And again, like we've done previously, if yours is in a little bit different order than what they're doing here, but you're doing the same stuff, that's fine. So just to get a little bit more practice with it, if we look at the lesson check number 5, how much interest will you earn by investing $1,200, interest rate of 2.5% per year for 6 years? So we're going to use this formula. $1,200 is what we're investing, 2.5%. We're going to move our decimal 2 places to the left. It's 6 years, and the interest is what we're trying to find. So we can just multiply all those together, and that would be $180. This formula is called the simple interest formula. There's actually a compound interest formula that's more often used. But this gives you at least an idea of what your interest amounts are. So this gives you an idea of how to work with percents, a percent equation, and percent proportion.